All right, today we're on lesson 6, and what we're going to do is determine the distance between any two rational numbers. So we're talking about rational numbers, and in order to be successful at this, you have to know what rational numbers are. So what rational numbers are is pretty simple. It's any number that can be written as a fraction. So take about 30 seconds and think about numbers that you could write as fractions, and we're going to make a list of some rational numbers so we know what we're talking about here. So some rational numbers that you would come up with would be any integers, mixed numbers, most decimals, so integers like 8, -7, 10, any whole number, even 0. 0 you could write as a fraction. Just 0 over 1, it equals 0. So any of those integers you could write as a fraction. If we wanted to write 8 as a fraction, all we do is put it over 1. So that would be our proof that it's a rational number. Mixed numbers, like maybe 2.5. Those already are in fraction form. And then most decimals, so maybe if we did something like, let's use 2.5 again, 2.5. How do you write that as a fraction? Lots of ways to do it. You could put, just as 2.5. We could take that 2.5 and write it as an improper fraction, and it would be 5 over 2, same value. So again, rational numbers are just numbers that you can write as a fraction, and most numbers that we deal with in 7th grade math are rational. Some that aren't, that we're going to work with, are pi. You've probably talked about it being 3.14. That's an estimation, but we'll work with pi a lot this year. And then some other not rational numbers are square roots that aren't perfect squares, like maybe the square root of 15, things that we'll get into later in the year. So today we're talking about rational numbers. We're talking about the ones that can be written as fractions. All right, you should have your classwork in front of you, and we're going to kind of work through this together. I'll do one, and you guys will do one, and we'll work our way through the video. So, exercise 1 says use the number line to answer each of the following. So I'll be person A, and you will be person B. So if we look here at the first one for person A, it says what is the distance between -4 and 5? So what you would do to solve that, it could seem pretty simple. You're just going to put a nice neat point at -4 and a nice neat point at 5, and we're just going to count the space between them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the distance between -4 and 5 is 9. So you're going to do the same thing. You guys are all person B. So look to the right, and it says, what is the distance between 5 and -4? Go ahead and do that. When you finish, your work should look something like this, and you should have counted 9 spaces between 5 and -4. So what they're going to have us do is find a pattern here. What do you notice that is similar between the one that you did and the one that I did? And what do you notice that is different? Okay, next one for person A. So that's going to be me. What is the distance between -5 and -3? So I'm going to put a point at -5 and a point at -3. I'm going to start counting from -5 because that was the first point. And I'm going to go 1, 2. So pretty simple. The distance between -5 and -3 is 2. You guys try it for this one. Okay, so what's the distance between -3 and -5? -3. -5. Now, -3 was mentioned first, so that's where we're starting. We have to go backwards, 1, 2. So we're moving to the left, but they're asking us distance. So just what is the space between? So again, it would be 2. And you're probably starting to see a pattern here. So let's do the other one quickly. Last one for me says, what is the distance? Zoom in for you. What is the distance between 7 and -1? So I'm going to highlight 7 first, -1 second. Looks like I'm counting backwards this time, but remember it's a distance, so they're positive numbers. 1, 2, 3, 4, 5, 6, 7, 8. So the distance from 7 to -1 is 8 units. You guys try the last one. And again, they're giving you the same integers, but in a different order. So they're giving you -1 first and 7 second. And 1, 2, 3, 4, 5, 6, 7, 8 should be your distance. So we're working with small numbers here, and they are integers. So what we're going to try to do instead of counting on a number line is we want to find a formula. Is there a way to find the distance between these numbers more efficiently so when they're big, we don't have to use a number line? So exercise 2 in our packet tells us what is the distance between 0 and -8. So we should understand how to work that by now. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. It's a distance of 8, but we're going to try to come up with the formula here so that we can always find these soon without the number line. And you're really going to like that when we have fractions, because counting the fractions on a number line can be a hassle. So here's how you do it with the formula. When we're finding distance between two numbers, it's always going to be a subtraction problem. So basically, you take the first number they gave you, 0, and we're going to do 0 minus -8. We did a short video the other day that showed when we have a subtraction integer problem, we're going to do something called keep, switch, opposite. So we're going to keep the first integer. We're going to switch to addition, and then the second integer we're going to change to its opposite. So instead of -8, it becomes +8. So for this one, whoops, we get a problem of 0 plus 8. 0 plus 8 equals 8. So that's a quick way to get the answer. We're going to start to apply that to some problems that are more difficult. So remember, distance between two numbers on a number line, you can always find it with subtraction. And we'll take a look at one of those involving absolute value if it comes out to be negative. So part B, we're going to get some rational numbers that are not integers. So it says, what is the distance between -2 and -1.5? So let's try that with the just the number line way first. So let's mark -2. And -1.5 would be here, between -2 and -1. So the space between those two dots is a half. It's not even one whole, because each one of these intervals is a whole, and we're only going half of an interval. So the answer to this one is going to be half. But let's try that with the formula, just so that it may make a little bit more sense. The answer is going to be 1/2. Let's take a look at it with the formula. So remember, that's always going to be a subtraction problem. So we're going to do -2, because that's where they wanted us to start, minus -1.5. So this looks messy, but it's really not if we do keep, switch, opposite. Okay, so keep the first integer, -2, switch subtraction to addition, and then we want the opposite of -1.5. It would be +1.5. Okay, so this is when we think back to those integer addition rules that we worked with last week. We have a problem of -2 plus 1.5. So the numbers have different signs. So when you do that, you want to circle the biggest absolute value and then subtract the absolute values. So 2, and you could do it as a decimal if you want to, 2.0 minus 1.5, 1.5. We're going to borrow, and we get 0.5. We get 1/2. So the distance between -2 and -1.5 is 0.5 or 1/2. And so we did that with the number line and with the formula. Let's try the next one. This one will actually be quite a bit easier because we do have integers. So what is the distance between -6 and -10? We can count it. 1, 2, 3, 4. So it's got a distance of 4. That's our answer. Let's practice it with the formula. So -6 is where we start. Always going to subtract. And -10 is where we end. So we come up with a problem of -6 minus -10. We're going to use that strategy called keep switch opposite. We're doing that because this is a subtraction problem, okay? You can always do that on a subtraction problem. So -6, we're going to switch subtraction to addition, and we want the opposite of -10, which is +10. Now it's an addition problem with different signs. So circle the greatest absolute value. Subtract the absolute values. 10 minus 6, that's 4. And keep the sign of the circled integer. So there you go, is another way to find the distance between -6 and -10. It's always going to be a positive distance because distance can't be negative. Running out of time on this video, so we're going to jump to example 2 where it says change in elevation versus distance. We're going to read that one, and then I will hit play on this and you will see that problem worked out. So let's read it. Alright, so if we look at where the hiker starts, he's starting at -200 because it's 200 feet below sea level. So I'm going to write down -200. He is going up to 580 feet above sea level, so we want the distance between those. Remember, to find the distance between, we're always going to subtract. And that number is +580 because it's above sea level. So if we use our formula, it should be -200 minus 580. This is a subtraction problem, so we're going to keep, switch, and then we want the opposite of 580, which is -580. And we have created an addition problem. Addition with same signs, remember all you do is add. So 200 plus 580 is 780. It comes out to be negative, but this is an absolute value because it's a distance. Okay, it's a distance he's traveling. So whenever something is written as absolute value, we're going to make it positive. And so 780 feet is the distance traveled, or the distance between where he is and where he's going. Now, this part tells us how should we interpret 780 feet in context of this problem. We should just think about it as the distance traveled. That's how far this hiker has to go.